Hi guys, this is for Unit 2, Module 3.4, Graphing Functions. The essential question, how do you graph functions? The answer, you can use a table of values to generate ordered pairs. So basically, again, a table with your domain and your range, okay? So this is just an example. And whatever values you get, let's say this example, you plug in a 2, all right, into your equation, and out comes a 4. This is actually an ordered pair. This would be considered 2 comma 4. That's what they're talking about right here. Now, if the graph is discrete, you would just plot the points. So in this example, let me use a different color here. There we go. So in blue, okay, if it was discrete, you would basically just plot the points. So you would have your graph, all right, with your x-axis and your y-axis. And let's say you had again 2 comma 4. Well, 1, 2, comma 4. 1, 2, 3, 4. Okay, so that'd be an example, just plotting the points given to you. All right. Now, continuous. Connect the points with a line or curve. So let's say if we go back to our last example here in our table, we had, let's say 4, comma, um, let's say 2. All right. In a sense of ordered pair, that would be 4, comma 2. Now, if we were to graph it discretely, it would look like this. So here we are at 4. I'm skipping here, so there you go. 4, comma 2, and that'd be right here. All right, so that would be discrete. Now, continuous, if this was the situation, let me use a different color again. I'll use, purple. Purple, there we go. So now if it was continuous in this example, you would have your x and y coordinate plane, Cartesian plane, and you would still have your points 1, 2, 3, 4, 1, 2, so 2 comma 4, and 4 comma 2. But the difference is, and there goes my pen, having fun again. Thank you, pen. But it's continuous, so you would actually connect the points and form your line. Okay, that's what they're talking about in a continuous situation. Okay, you still have your points from your ordered pairs. You just have to connect them now. All right. So let's see our first example. So in our first example, we have a standard equation given to us. Now, first things first, we have to graph the function for the given domain. So this is actually considered a discrete graph because they give us a set domain. We can only use the values of 0, 3, 6, and 9. So first things first, let's go ahead and rewrite our standard equation into something a little bit more familiar. Y equals mx plus b, or slope-intercept, okay, form. So let's go ahead and remove the plus 3y. What's the opposite of adding by 3y? Subtracting by 3y. And just remember, what you do to one side, you have to do to the other. Then you're going to have, oops, I'm sorry, first mistake of the day. Why get rid of the y? Let's get rid of the x, right? It's supposed to be y equals mx plus b. So glad I caught that. Let's get rid of the plus x, or positive x. So we'll do that with subtraction. What you do to one side, do to the other. You have 3y left over on the left-hand side, and then the negative x plus the positive 15, right? How do you get rid of the dividing 3 on the y? Or I'm sorry, the multiplying 3 with division. What you do to one side, do to the other. And you should get this equation right here. Y equals negative 1/3, because, again, 3 divided by 3 is 1, right? There you go. And the negative x divided by 3 is really just negative 1x over 3. So you could just say that too. 15 divided by 3 is positive 5. Okay, so you should get that right there. Now, the domain is specified, it's discrete. So let's try with 0. Okay, substitute in for 0. Anything times 0 is 0, and 0 plus 5 should give you 5. So you have 0, comma 5 for your ordered pair, and then you can go ahead and graph it. Looks like these guys jump up by 2s, so that's something to take note of for the units for the graph. Now for 3, okay, another part of our domain. Substitute in. Negative 1/3 times 3 is the same as saying 3 divided by negative 3, which is really just negative 1. And negative 1 plus 5 should get you 4. So you have, again, we plugged in 3, and out came the 4. So we have 3, comma 4, which is right here. Okay. All right, now with the 6, substitute in for your 6. 6 divided by negative 3 is really just negative 2. All right, notice how I'm saying instead of negative 1/3 times 6, it's the same as saying negative 6 or 6 divided by negative 3. So notice the duality because your numerator is 1. Okay, so that's why I'm saying it the way I'm saying it. All right, so again, negative 2 plus 5, which is the same as saying 5 minus 2, which is just 3. We plug in a 6, out comes a 3. So 6, comma 3 is right here. There we go. All right, last but not least, 9. Let's substitute it in. 9 divided by negative 3 is a negative 3, and negative 3 plus 5 should give us 2, and it does. So we plugged in a 9, and out comes a 2. So we have 9, comma 2, right here. Okay, this is a discrete graph, okay? It's discrete, and the big, the flare in the window type deal, this lets you know right away you're going to have a discrete graph, okay? All right, graphing functions using domain of all real numbers, okay? So all real numbers, okay? That's Greek symbols just saying the same thing. All right, so graphing functions using domain of all real numbers. Step 1, use the function to generate ordered pairs by choosing several values of x. So to get an idea of its placement, we pick some relative values that can give us a sense of positioning. And we'll see an example of that. Step 2, plot enough points to see a pattern. Pattern recognition is what separates most human beings from most animals. Okay, even artificial intelligence is trying to figure that out too. All right, so we're going to see a pattern pretty soon. Step 3, connect the points with a line or smooth curve. Now, because we're talking about all real numbers, we are talking about not discrete. This is continuous. So they have to be lines or smooth curves, no single dots anywhere, okay? So example 2, notice how they don't say any set domain, right? That's because this situation is assuming it's all real numbers, all right? So using several values to generate x in order to values. So they picked some relative numbers, negative 3, negative 2, negative 1, 0, 1, 2, and 3. They went ahead and substituted them in, all right? So the negative 3 gets substituted. It gives us a positive 9 because negative 3 squared is the same as saying negative 3 times negative 3, which is really just positive 9. We plugged in a negative 3, out comes a 9. And the same thing occurs with all the negatives. You substitute them in. Negative 1 squared is negative 1 times negative 1, positive 1. Negative 2 times negative 2, okay, or negative 2 squared, positive 4. 0 squared gets you 0, so plug in 0, get a 0. Plug in a 1, get a 1. Because 1 squared is just 1 times 1, which is 1. 2 squared, 2 times 2, that's 4. So plug in a 2, get out a 4. 3 squared, 3 times 3, which is 9. Plug in a 3, get a 9. Okay, so notice these are our ordered pairs right here. Okay, go ahead and plot them, and if you can see, we actually do. They plot them, and out comes a pattern. Okay, pretend that the line's not there yet. That all you have all these points. Now they're all real numbers, so we know it's continuous. But do you notice the pattern? Okay, it looks like there's a pattern, right? Well, this guy is, looks like he's a direct reflection over there, and this guy looks like he's reflected over there, and right, you see the pattern? So that's what they're talking about when they say pattern. So you see the pattern, let's go ahead and connect all the lines. And they draw the lines. They draw, actually it's not a line, they draw the curve. Okay, this is actually what we call in the industry a parabola. Okay, so again, they connect the dots because this is continuous, all right? So your turn number 1, what I want you to do is go ahead, They already picked the points for you. They already picked your domain, your samples, okay? Your domain in the situation, again, is all real numbers, okay? Go ahead and plug these in, all right? Plug in -1 for our function, okay? So 3 times -1 minus 5 is really just -3 minus 5. 3 plus 5 is 8, but since both of them are negative, it'll be -8. You plug in a -1, you should get a -8, okay? Go ahead and do the same thing with all the others, all right? So test them out, plug them into the equation, see what you get, okay? Once you get them, plot your points over here. Okay, that's an arrow. So plot your points. Once you get all your points, you should see a pattern and draw your line, okay? Your turn number 2, same deal. Notice there's not a table anymore, okay? I'm taking the training wheels a little bit off. So what you are going to do to make sure you understand the function idea of things, you're going to pick some points, all right? Tell you what, if you like, you can pick these points. All right, and then plug them into your equation, all right? So in this situation, your equation is y equals -x squared. And then whatever you get on your output, so in and out, if you plug in -3, y should be, let's see, -x squared. So there you go, plug it in. All right, so for example, -3 squared is -3 times -3, which is +9, but this negative out here, right, still exists. So, oops, sorry, that is a +9. But what's negative of a +9? A -9. Okay, so go ahead and plot these points, plug them in, get your ordered pairs, and you're going to start plotting over here on your graph. Once you see the pattern, connect them. You might be a curve. It just depends. If you see some kind of curve with the points, draw a curve. Your turn number 3, same thing, set up your table. And I want to let you decide what values you want to use for your equation, okay? Choose wisely. You don't want to pick outrageously huge numbers like 100 because as you see, your graph here kind of ends off at -10 and 10, all right? So again, pick some numbers. Pick, 1, 2, pick a couple numbers. Pick five numbers, all right? Test them out and try it. Go ahead and do that on the board with your team, all right, with your group. All right, graph and find the values, example 3. So we're going to find specific values. So use the graph to find the value of f of x when x equals -2. Well, if we were to do that, we would have to first plug in the value. So instead of f of x, it'll be f of -2. Okay, because now we're wanting to plug this in. So to substitute. So -1/2 x, but instead of x, it's -2 plus the 3. Now, when you read this, it's really -1/2 times -2, which is the same as saying -2 divided by a -2, which should give you a +1. And 1 plus 3 is 4. Therefore, the value for this guy is written like this. F of -2 equals 4. We plugged in -2, and out came 4. Okay, so that's just the idea of function notation. So if we were to plot this, it would be at -2, comma 4. And there you go. There is our value. Your turn number 4 is the same thing as my last example that I just did, except this time x equals 3, and your function is this one right here. Okay, go ahead and substitute it in. There's your hint. And there you go, find your value. Thank you guys, and have a wonderful day. And let me know if you have any problems or questions, all right? Don't be confused.